Hey, sixth graders. Today I want to build on what we learned yesterday about coordinate graphs. So we're going to review coordinate graphs really briefly, and then we'll talk about where the ordered pairs that we get come from. So as you learned yesterday, we know that we're going to take, what we're going to do is we're going to take what we've been doing and build on it. But in order to do that, we need to know about the coordinate plane. And this is what you learned about yesterday. The coordinate plane is called it because it has two coordinates, an x coordinate that goes side to side and a y coordinate that goes up and down. We learned that yesterday. We use these coordinates by using the axis. The x-axis travels from side to side. The y-axis travels up and down. And the key here is that we can use these coordinates, this x coordinate and this y coordinate, to find any unique place on the graph. And you practiced this yesterday. Every spot that you put on here is a unique set of coordinates, and the graph is always given by the ordered pair x, y. X comes first, then y comes second. Always. And if we are always consistent with that, we can find any point on the line. For example, if we wanted to find the point 3, 4, that would mean x is 3 and y is 4. Then we can do that by going over 3, 1, 2, 3, and up 4. 1, 2, 3, 4. And the point would be right there. The point 3, 4 is right there. So over 3, up 4. X is side to side, y is up and down. Again, you covered this yesterday and did some activities on this. We can try more. We can put a whole bunch of on there. I'm going to go through this really quickly because the part I really want to get to is where do these ordered pairs come from? So again, this would be 1, 7, so we'd go over 1 and up 7. Over 9 and up 1. Negative 3, 5. So in this case, we would go backwards 1, 2, 3 because that's the x. The x is the side to side, so backwards 1, 2, 3, and then up 5 would put us right here. The next one would be 6 and negative 9, so we would go over 6, and then we would go up negative 9. Well, going up in a negative direction is really going down, so we would go down to negative 9 and then up right here. Negative 3, negative 4, that means both of them are going to be in negatives. Negative 3 going back 3 in the x, then going down 4 in the y. It's going to put us right here. 0, negative 4. This one's important because it stays at 0 for x. x0 is this line right here. And then it's going to be down 4 and y, which means we're going to go down to this spot right here. And finally, 3, 0 would be 3 on the x, and then 0 on y, which is going to keep us right on this line right here. All right, and we can keep going over and over. Okay, but this is the key piece. Where do we get these ordered pairs from? Do we just make them up out of thin air? Well, that is where functions and tables come in. We've been studying functions, and we've been studying tables. So, if we are given the function y equals 2x plus 3, then we can make a table for that. So let's do that. If I do a table for that, then I know that 2 times negative 4 plus 3 is going to give me negative 5. And I know that 2 times negative 3, well, that's negative 6. Plus 3 means I go up 3 from that. So negative 6, negative 5, negative 4, negative 3. And if you remember correctly, we've done the 0 case. Remember where the 0, if 2 times 0 is 0, then 3, add 3, and we're going to get plus 3. So that's where all of these numbers from. That's just picking some input values and getting some output values out of that. We've done this. We have practiced this a few times. We take our x value, we put it into the equation, into the function, we do what it says, and we get an output. So who cares? Why use this? Well, if you notice, if the input is x and the output is y, I have a pair of numbers here. I have an x value and I have a y value. So the beauty of what we're doing with graphs is that I can actually turn this table into a graph and look at it. So let's look at how that's done. Here is a graph. Let's look at the first point. Negative 4, negative 5. I go down, over back 4 and I go down 5. There's my first point. Negative 4, negative 5. Negative 4, negative 5. Well, where's my second point going to go? I have an x of negative 3 and a y of negative 3 as well. So back 3 and down 3. My next point is going to go right here. There's my second ordered pair. Then negative 2, negative 1, so back 2, down 1. There's my third ordered pair, negative 1, 1. That's because negative 1 times 2 is negative 2 plus 3. So negative 2, negative 1, 0, 1. Aha, so it's going to be at x equals negative 1 and y equals 1, right here. And what do you notice about these lines so far? What do you see as you look at these? Well, I see a pattern. In fact, I see a very clear pattern that these are all in a line. They're all making a line. Let's see if that holds. 0, 3. That would mean x equals 0, 3. Does that fit with my idea that there is a line? Boy, it sure feels like this is all part of a line. What is going to be next? 1, 5. 1 and 5. And then 2 and 7 goes up here. And then 3 and 9 goes up here. And 4 and 11, well, actually, that would go off my graph, but I can still put it in there. 4 and 11 goes here. What do we see? We see that all of these ordered pairs work together to make a line. And the reason that happens is because there's a predictable amount of space between each of these. Remember how we predicted that this would go, that we would find the equation by predicting how far up each one of these goes. So we have 5, goes up by 2, it goes up by 2, it goes up by 2. Every time it's going up by 2 because it is being multiplied by 2. Well, look, it's going up by 2, it's going up by 2, it's going up by 2, it's going up by 2. So this set of pairs actually creates a picture of this graph. And so if we want to, we can actually connect them all with a line. And you can see very clearly that this line falls right on top of all these points. Now, it's not perfect, but that's just because my PowerPoint here won't let me put them exactly where I want to. If I had control, it would go exactly right there. But it's close enough to show that this is what happens. And so that's why these ordered pairs can be really, really powerful tools for us to use in math. Because I can take those ordered pairs, I can put them on a graph, and they will show up and make the picture of this function. So I can call this function y equals 2x plus 3 because this is the line that creates that function.